Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is Exploration.
Every week on Exploration, we discuss the fascinating world of science and its implications for society. And today, we're going to devote the entire to outer space. That's right. We're entering perhaps the second golden era of space exploration. And we'll talk about some of the recent developments. Did you know, for example, that we almost had a near tragedy in outer space? The Soyuz space capsule, which was designed to send our astronauts from Kazakhstan into outer space to the International Space Station, had a misfire. Luckily, the astronauts there had an escape pod whereby they could parachute back down to the planet Earth. And the question is, well, why didn't we use that escape mechanism years ago when we lost 14 brave astronauts to accidents in space? So we'll talk about the risks of going into outer space. And also recently, NASA and the European Space Agency and the Japanese have sent probes to the Sun and to Mercury. And some people are saying, well, why? I mean, there's no life on the Sun. There's no life on Mercury. Mercury is a desolate planet. It's waterless. It's scorched by the solar flares from the Sun. So what do we have to gain by sending probes to the Sun and probes to Mercury when all the attention has been focused on planets like Mars and Saturn? And then let's see a few things about the Moon. Yes, we are going back to the Moon. Elon Musk, the billionaire, is sponsoring a new rocket, the BFR rocket, to take our astronauts not just to the Moon, but also to Mars. Now, he's a little bit coy about what the BFR stands for. We know that B stands for big, R stands for rocket, and F, well, that could pretty much stand for anything you want. And then let's say a few things about planet Mars. National Geographic is sponsoring several seasons worth of documentaries concerning Mars. It also uses actors and actresses to dramatize some of the hazards of going into outer space. In fact, I'm one of the talking heads in the program. And then lastly, we'll answer the question, well, why bother? I mean, outer space is so forbidding. It's so expensive. Why even bother to go into outer space when we have so many problems here on the planet Earth? Well, let's just jump right into our special program about outer space. As you mentioned, first of all, we had a near miss. That is, the Soyuz spacecraft, which sends our astronauts into outer space to the International Space Station, had a misfire just minutes after launch from the Kazakhstan spaceport. And you had to hold your fingers crossed because an escape capsule was ejected from the crippled spacecraft. And fortunately, the parachute unfolded and the astronauts safely landed back on the planet Earth. And then you may ask yourself another question. Well, we dodged the bullet this time, but why in the past didn't we have a similar escape mechanism for our astronauts? I mean, NASA lost 14 astronauts because of two accidents with regards to the space shuttle. I mean, why? Why didn't we have that escape capsule back then? Well, first of all, we've been sort of brainwashed by the media into thinking that space travel is a Sunday picnic. Well, it's not. The misfire rate for a booster rocket going into outer space is about 1%. 1% of the time, you enter that space capsule and you never come back. That's right. We're, 60 years into the space age, and still we cannot get that number much less than about 1%. And if you think about it, the space shuttle had 2 accidents, and how many missions were there? Roughly 200 missions. And so we have the situation where the space shuttle, with 2 explosions of the module, actually happened more or less on schedule. 1% of the time, you never come back. And the question is, what's some of the reasons why? Well, of course, rockets have lots of moving parts, and you're sitting on millions of gallons worth of rocket fuel. And so its conditions are ripe for an accident. But there's also another reason why we have accidents with regards to our rockets, which was revealed by Nobel laureate Richard Feynman. Richard Feynman investigated the shuttle accident, and he met with the senior engineers for NASA. And he gave them each a sheet of paper. And he asked them to write on that sheet of paper what they thought the estimates were for a catastrophic accident in space. Well, these were engineers, seasoned engineers, and they all wrote down something like 1%. Something like 1% of the time, yes, our rockets are going to blow up. However, one person refused to turn in that sheet of paper. Finally, when he was asked to write down the probability of another accident, he wrote down the word never. Now, that violates common sense, that violates the laws of statistics, and probably the laws of physics. He wrote down never. And then Feynman figured it out. That man who wrote down never was just like all the other engineers in that room, except for one thing. And that was, he was an engineer who got promoted into the ranks of management. And in management, your priorities are different. If you're that engineer on the ground, you want to, A, make sure that rocket goes up, and B, you want to make sure that that rocket doesn't explode. But you see, once you become a senior bureaucrat, once you're in charge of budgets and all these other considerations, many of them political, then all of a sudden your priorities slowly begin to change. And wishful thinking begins to set in because you have budgets to meet, you have deadlines to meet, and that's why he wrote down the word never. Well, get used to it. We're going to have other accidents with regards to our astronauts, and hopefully they will have an escape mechanism each time. Now, why didn't we have an escape mechanism for the space shuttle? The answer is cost. We could have done it, but it costs too much money, and as a consequence, 14 of our brave astronauts perished in the process. However, the people who actually engineer these rockets, make these rockets, they know that, yes, many times these rockets misfire. For example, when you look at the planet Mars, there's the Mars jinx. The Mars jinx is the fact that only about 1/3 of the space probes that we send to Mars actually make it. 2/3 of them never make the red planet. In fact, Elon Musk, who is fielding his own Moon/Mars rocket, the BFR, was asked whether he would want to go into his own capsule and go to Mars. Well, he said yes. He'd be delighted to go to Mars, except not on impact. In other words, if it means dying on Mars, he would prefer not to go into outer space, even on one of his own rockets. And speaking about rockets, the Sun, Mercury have been in the news. NASA is sending space probes to other areas of the universe, along with the Japanese and the European Space Agency. First, the Sun. Well, that got a certain amount of criticism because people said, well, there's no life on the sun. It's hot. We know it's hot. So why bother to send a probe to the sun? It's expensive. The instruments would be fried if they don't go on the right trajectory. What do we have to learn? Well, the answer is quite a bit. It turns out that much of the weather on the planet Earth is directly or indirectly controlled by the sun. And we know actually very little about the sun. We have the equations for thermodynamics, the equations for fusion. That gives us the gross properties of the sun, the rate at which it burns hydrogen, and the rate at which it emits energy. But what about fluctuations? For example, during the Middle Ages, we had the Little Ice Age. That's right. If you take a look at paintings done during a certain era of the Middle Ages, it turns out that these paintings show that many of the famous rivers and lakes of Europe, which are ice-free, were frozen solid during winter time. Ice skating in lakes that today have no ice at all. And so we know that things were colder. Things were a lot colder during the Middle Ages, and that's called the mini ice age. And the question is why? Well, we don't really know. One theory is that perhaps the sun's energy fluctuates, but that's just a theory. We want to test some of these theories, and that's one reason for launching the probe to the sun. Another reason for sending a probe to the sun is because once in a while, the sun has a temper tantrum, blows its top, and sends a huge amount of radiation into outer space in the form of a solar flare or a coronal mass discharge. The last big one was in 1859 called the Carrington event. Google it, Carrington event. It was an event that we hope will never be repeated again, because back then, in the 1800s, it not only caused a show of northern lights because of all that radiation coming from the sun, it turns out that the northern lights went as south as Cuba. That's right, people in Cuba could read the newspaper by the light of the northern lights. And telegraph wires went berserk. All of a sudden, the air was electrified, meaning that telegraph wires would spontaneously start up and cause sparks and fires. Now, we physicists today can take these two facts, the fact that the northern lights went all the way down to Cuba, and the fact that telegraph wires were set afire, and then calculate the electric field density that caused these things. And the numbers we find are incredible, absolutely staggering. It turns out that physicists estimate that if it were to happen today, not in 1859, but today, property damage would be on the order of $2 trillion. That's trillion with a T, not a B. And that means that not only will our satellites be knocked out because of a solar flare, it also means that power stations on the Earth, all over the Earth, could get knocked out. Meaning that all of a sudden you have a blackout, but the rescue crews are not going to come because they too have been afflicted by the gigantic solar flare. In other words, your food is going to rot. In just a few days, we may have food riots. Commerce will come to a halt. I mean, simple things like credit card transactions will be knocked out. Recently, we had a blackout that hit Times Square, and sure enough, all the tourists in Times Square could not check into their hotel room, and they had to sleep in the lobby as a consequence in Times Square. This means that power plants will be knocked out, satellites will be knocked out, astronauts in outer space will have to be extremely careful. We're going to be thrown back maybe 100, 200 years into the past. And that's with a solar flare. The big question is, can it happen again? And the answer is yes. In fact, it almost happened. We now know that sunspots are like cannons. Sunspots hurl enormous amounts of plasma in a solar flare into outer space, sort of like shooting bullets out of a gun. Fortunately, there's a lot of real estate out there. So even though a solar flare is shot out of the sun from its sunspots, usually they miss the Earth. However, we now track these things. We didn't before, but now we're very interested in this, and we dodged the bullet. Yes, just a few years ago, we had another potential Carrington event, but it missed the planet Earth. If it had hit, we would still be in the phases of recovering from that horrible coronal mass ejection, which could wipe out telecommunications on the Earth, because we are so dependent. We're so dependent on electricity for the internet, for communications, for daily transactions, for industry. Like I said, we'd be thrown back 100, 200 years back into the past. Now, what is the frequency overall of these coronal mass discharges? We don't know. Going to the poles, we can get ice cores and analyze ice and snow that fell thousands of years ago. And when we do that and calculate the time at which the snow fell, we realize that, yes, there was another Carrington event a few hundred years ago. And so it means that, A, these coronal mass discharges happen almost all the time, but fortunately, we dodged the bullet. But B, sometimes we get a direct hit. And when that happens, watch out. So far, the only knowledge that we have is that they take place on a matter of centuries, but Who knows for sure? Also, speaking about outer space, the moon is back in the news. Given the fact that we had the first great era of moon exploration in the 1960s, then it collapsed. Now it's coming back. We're entering now the second golden era of lunar exploration. But why? Well, you have to realize that back in 1966, the Apollo space program consumed 5% of the entire federal budget. Now, let me repeat that again. In 1966, the Apollo space program soaked up 5% of every tax dollar that you send to the federal government. That is unsustainable. You can't maintain that forever. And sure enough, just a few years later, the United States lost interest in going back to the moon. We beat the Russians. We realized how expensive it was, and it was simply knocked out of the federal budget. And we have not been to the moon in 50 years as a consequence. Now things are changing. Costs are dropping. You know the movie The Martian, starring Matt Damon? That movie cost $100 million to make. $100 million. But the Indian government sent a probe past Mars for $70 million. This means that a Hollywood movie about going to Mars actually costs more than actually going to Mars. That's how cheap space travel has become, so that even the Indian government can field successful space launches and take gorgeous photographs of the planet Mars. Now, this also means that reusable rockets are going to lower the cost of space travel even more. Elon Musk and also Jeff Bezos, these are two billionaires heavily investing in rockets. In fact, we may not have one moon rocket. We may have 3 moon rockets capable of reaching the moon. One of them is the SLS. That is the booster rocket of NASA, paid for by you and me. Our tax dollars pay for the SLS rocket. It's scheduled to orbit around the moon in late 2019. Next year, we're going back to the moon. Now, Elon Musk, not to be outdone, has the Falcon Heavy. The Falcon Heavy rocket has a capsule, the Dragon module, fully capable of reaching the moon. So we have 2 moon rockets ready to go. They've been fired up and tested. So we have 2 moon rockets, 1 moon rocket paid for by taxpayers, the other by a private billionaire. And Jeff Bezos, richest man on earth, not to be outdone, he's also invested in a spaceport in Texas, where he hopes to shoot the new Armstrong rocket to the moon. Now, it hasn't been tested yet, and is still in the drawing phases, but think about that. Not 1, not 2, but 3 moon rockets capable of sending astronauts to the moon. And Elon Musk, ever the showman, not to be outdone, has and Elon Musk of SpaceX, ever the showman, also announced that a Japanese billionaire has bought out all the seats on his moon rocket, meaning that, yes, passengers are already signing up to go back to the moon. This means, of course, a whole new renaissance in space exploration. Some people are saying that with the falling cost of space travel, mom and dad may be able to go into outer space. Our kids may be able to fulfill some of their fantasies about becoming an astronaut. And our grandkids may even honeymoon on the moon. That's right. It only takes 3 days, a hop, skip, and a jump to reach the moon. You could go to the moon and come back on the weekend. So some people think that space tourism could be the way to go. And then the next question is, why? Why are we doing this anyway? After all, it is expensive, even with the falling price of rocketry, and it is dangerous. 1% of the time, as I mentioned, rockets tend to blow up. Well, I once interviewed Carl Sagan for this radio program, and I asked him that question. I said, look, We have so many problems on the Earth: global warming, nuclear proliferation, germs. Why go to the stars? And he gave me an answer that sort of caught me off guard. He said, both, we have to become a two-planet species. Why? Because we live in the middle of a cosmic shooting gallery. So many asteroids, so many comets and meteors whizzing by. We are blissfully unaware of the fact that they are near misses all the time. Now, of course, these things don't happen often, thank goodness, or else we wouldn't be here right now to talk about it. But it does mean, he said, that at some point we have to leave the Earth. At some point, it's simply going to be too dangerous to put humans on the planet Earth. On a scale of, for example, hundreds of years, we have the threat of a supervolcano, like the one in Yellowstone National Park. On a scale of thousands of years, we have to worry about another ice age. That's right, in about 10,000 years or so, where I'm sitting right now in Manhattan, we'll be under perhaps a half a mile of ice, like it was 10,000 years ago. And then on a scale of tens of millions of years, we have the possibility of another killer asteroid, just like the one that knocked out the dinosaurs 65 million years ago. You know, the dinosaurs did not have a space program, and that's why they're not here today. We do have a space program, and so we can also choose our fate. And then, let's do an experiment. Dig right underneath your feet right now. That's right. Dig right through all the concrete and wood and rock right underneath your feet. What are you going to find? Fossils. Lots of fossils. But these fossils are of life forms that are extinct. In fact, 99% of all life forms eventually go extinct. Extinction is the norm for Mother Nature. Let me repeat that again. Many people have this feeling that Mother Nature is warm and cuddly. However, extinction is the norm. Of all the life forms that have been on the planet Earth, only the tiniest fraction of them are still on the planet Earth. So we have to buck the odds. The odds are 99.9% that we too will also go extinct for any number of the reasons that I mentioned. And that's why Carl Sagan said, look, as an insurance policy, as plan B, as a backup plan, why not have a settlement on Mars? Now, he wasn't advocating evacuating the Earth. No, that'd be impossible. It would cost too much. And why bother? No, we're talking about a settlement that is self-sufficient. In other words, they're on their own. Once they get there, they're going to have to biologically engineer crops to grow on the surface of Mars. They're going to have to mine the ice to extract drinking water and hydrogen and oxygen for rocket fuel and for breathing. They're going to have to get sunlight from the sun in order to energize their machines. They have to become self-sufficient. And that's one of the reasons why, cost-wise, only the first settlement will be expensive. And after that, the colony will be self-sufficient. So in other words, according to Carl Sagan, we have no choice. We have to leave the Earth. Now, on a scale of billions of years, we will face the death of the sun. Now, the poets like to say everything will end in fire or ice. Well, I'm a physicist. We can now answer these questions. How will the Earth die? The Earth will die in fire because the sun will expand into a red giant star. One day we will have the last nice day. The sun will expand from one point of the horizon to the next. It means the oceans will boil, the mountains will melt, and from dust to dust, ashes to ashes, physicists say, from stardust we came, and stardust we will turn. Now, how will the sun die? The sun will die in ice. It'll burn out its nuclear fuel and eventually become a dead black dwarf. And how will the Milky Way galaxy die? We see the galaxy every night lighting up the night sky. The galaxy will end in fire because it will collide with Andromeda, a nearby galaxy. And since Andromeda is bigger than the Milky Way galaxy, it will gobble up, eat up the Milky Way galaxy. And how will the universe die? Well, we're not sure, but the latest evidence seems to indicate that the universe will die in ice. It'll expand forever one day we will look up at the skies and see nothing. All the stars will have moved away so fast, light cannot even reach us. And at that point, temperatures will plunge to near absolute zero and all life will cease to exist. Sorry about that. Well, there is one loophole. One loophole in all this is to exploit Einstein's equations, which allow for wormholes. Maybe one day we'll have enough energy, trillions of years from now, to build a lifeboat, an interdimensional lifeboat, whereby we can leave our dying universe and enter another young universe, and then perhaps even mess up that universe as well. Now, this is not pure science fiction. It turns out one of the solutions of Einstein's equations give you wormholes. In fact, the late Stephen Hawking posthumously has published a book where he says, yes, wormholes, even time travel, they are solutions of Einstein's equations, and who knows, they may in fact be possible. Now, this, of course, is not for us. It's for technology millennia, millions of years, maybe even billions of years more advanced than us. But at that point, billions of years from now, civilization may be able to harness enough power to create a hole in space, stabilize that hole, and use it for the ultimate gateway to another universe. So when the universe dies, we do not necessarily have to die with the universe. Now, all this may sound like science fiction, and much of it is. However, it's based on Einstein's theory of general relativity and the quantum theory. It turns out that, yes, Einstein's equations do allow for the possibility of tearing the fabric of space-time. The quantum theory opens the possibility of stabilizing that tear in the fabric of space and time. And perhaps in the future, one day we may be able to escape the death of the universe itself. So human ingenuity has always been with us. It's the reason why the dinosaurs are not here today, but we are. We are here today, and we're here to contemplate even the most horrific consequences that could befell our universe. So it means that human ingenuity may once again prevail. So when people ask me the question of what use is physics and string theory and the unified field theory, I tell them that, well, maybe one day it'll save us from the death of the Earth, the death of the sun, the death of the galaxy, and the death maybe of the universe itself. Perhaps it may be the saving grace for all intelligent life in our universe. Not bad for a theory. Good day.